So let's consider these quadratic functions based on the things we know to look for. First of all, in y equals 5x squared minus 3, well, that highlighter was a lot darker than I expected. But 5x squared, the coefficient of the x squared term is 5. Positive coefficients x squared terms give us smiley parabola, so we know this will be a smiley parabola. Negative x squared terms give us frowny parabolas, so if we counter those later, we'll just keep it here as a note. We also note the larger this number, the coefficient of the x squared term, the steeper or narrower our parabola will be. So our little rule will be the bigger the coefficient of x squared term is, the steeper it'll be, and we might as well add the closer to 0 the coefficient of the x term is, the wider the parabola will be. So on this first one, we expect it to be positive, so swooping up, and pretty steep. Next, we look at the the constant term, which happens to be negative 3 here. So our parabola is going to shift down 3 units. So here is y equals x squared. And if I put a 5 in front of the x squared, it makes the parabola much steeper and narrower. And if I subtract 3, do minus 3 as my constant term, it shifts the parabola down. We can see that now the y-axis is actually at negative 3. So the constant term shifts your parabola up if it's positive, and it shifts your parabola down if it's negative. Your constant term is also your y-intercept. Now that we have all the rules, let's take a look at the next one. This one has no constant term, so it's not shifted up or down, it'll go through the origin. The coefficient is 2/3, that's less than 1, so it's going to get a little bit wider than the parent function. And it's a positive coefficient of, it's a positive coefficient of x squared, not x. That was not even a quadratic. Let me fix the rest of them too. Much better. So this will be wide, it'll be smiley as in opening upwards, and it'll go through the origin because it's not shifted. And here they are graphed out. You can see the parent function in red, and y equals 2/3 x squared is just a little bit wider, still goes to the origin. The next one, we have y equals negative 10x squared plus 5. We can see negative 10 is actually very steep in the negative direction. That's because it's the exact same line as 10x squared, but reflected downwards. So very steep in the negative direction, and it's shifted up by the plus 5. So here we can see y equals negative 10x squared plus 5. You see it is very steep and going down, but it also got shifted up to 5, so 5 is the y-intercept. The next one is y equals negative 1/20 x squared. 1/20 is a very small number, very close to 0, so it'll be very wide. It's going to go downwards because it's negative, and it won't be shifted, so it'll go through the origin. And here you can see it is very wide. It goes to the origin, and it's going down just like we predicted. And last one, we have y equals x squared minus 7. You see the coefficient of the x squared term is 1, so it's just going to be the regular width, and it's going to be shifted down 7. And x squared is a positive term, so it's going to be a smiley parabola. Alright, here it is. The way I have the graph zoomed, it's just so far down. If we go down to check it, there it is at -7, looking just normal. So these are very helpful clues about your quadratic function, well, about your parabola that it graphs, based on what you can see from the terms, the constant terms, and the x squared terms by its coefficient.